Today we're going to teach you everything you need to know about correlation. Correlation measures the direction and strength of a linear relationship between quantitative variables. The symbol for correlation is R, which is also called the correlation coefficient. Some things you should know about correlation is that representative value R will always fall between -1 and 1. When R equals 0, there is no correlation between the variables. When R equals 1 or -1, it is a perfect relationship between the variables. Depending on how close to 1 or -1 R equals determines how we describe the relationship. This number line shows what words to use when describing the relationship. It will be either strong, moderate, or weak, depending on where it falls on the number line. From 0 to 0.5 is considered weak, from 0.5 to 0.7 is considered moderate, and 0.7 to 1 is considered a strong correlation. The same values are true when negative as well. There are several important things to remember about R. First, R is heavily influenced by outliers. Second, R does not change when you change x and y axes. Third, R can only be calculated for quantitative variables. Quantitative variables are variables that can be measured. Fourth, R has no units associated with it and is not affected by change in units. For instance, going from liters to milliliters has no impact on R. Fifth, R is not the slope. And the most important thing to remember when talking about correlation is that correlation does not equal causation. Now we'll teach you how to find R with a calculator. First, you will hit Stat, then select Edit, and enter in your data into L1 and L2. Next, hit Stat again and go over to Calc. Scroll down and choose number 8. It will say linreg A plus BX. This will give you the numerical values. To see the graph, you will hit Graph, then zoom 9 and select number 9. You will then have a visual as to what R looks like. And don't forget that your diagnostic must be turned on. Here are some examples of correlation graphs. When describing a graph, you always want to talk about direction and strength. In graph 1, the direction is negative with a weak correlation. This R value would be around -0.4. In graph 2, there is a strong negative correlation with an R value around 0.9. The second page shows more types to help you distinguish graphs. Graph 1 shows a weak positive linear correlation with an R value around 0.1. Graph 2 shows a very strong positive linear correlation. Remember to always say the graph is linear. Here is an example of a correlation problem. The problem is comparing the relationship between flavors. The data is seen for chocolate being 10, 10, 4, 9, 10, and 2, and for mocha being 10, 4, 5, 7, 1, and 2. To find the answer, you'll input all of your data into Stat, then edit, and go to Stat, calculate number 8 to find correlation. For all of our data, we use either information from our composition book or scicnut.com/statistics/word problems correlation 9. This has been Ethan Streeter, Michael Ha, and Carter Mitchell. Thank you for watching.